Hello and welcome. In this module, we're going to explore SQL Stored Functions. Stored functions are user-defined functions designed to create and execute functions as needed. We will learn how these functions work and how to create your own. Let's dive into creating user-defined functions. So, what exactly are SQL Stored Functions? A stored function is a database object that contains a set of SQL statements and performs a specific operation. The key characteristic of a stored function is that it always returns a value and can be called from SQL statements. Now let's understand the key differences between functions and procedures. Functions must return a single value, whereas procedures may or may not return a value. Functions can be used in select statements, making them suitable for calculations and data transformations within queries. Functions typically cannot modify the database state, ensuring data integrity. Functions are more focused on computation, whereas procedures can perform a broader range of tasks. Let's take a look at the basic syntax for creating stored functions. The basic syntax is create function _name, parameter 1 data type, parameter 2 data type, returns return _ data type begin comment function body comment return value. Comment must return a value comment end. Here are some key components to keep in mind. The function name should be descriptive, clearly indicating the function's purpose. Parameters can have default values in some database management systems, allowing for more flexible function calls. The return type must match the value being returned by the function, ensuring data consistency. The function body must contain a return statement to provide the output value. Let's walk through a simple SQL function example. This is the code. Comment function to calculate discount comment create function calculate _ discount, price decimal 10 2, discount _ rate decimal 4, 2, returns decimal 10, 2 begin declare discounted _ price decimal 10 2. Set discounted _ price equals price minus price times discount _ rate divided by 100, return discounted _ price, end. Now let's see how to use this function. You can use it in select statements to calculate discounted prices for products. You can also use it in where clauses to filter products based on their discounted prices. For example, here's how you can use it in a select statement. Select product _ name price, calculate _ discount price 15 as discounted _ price from products. And here's how you can use it in a where clause. Select asterisk from products where calculate _ discount price 20 less than 50.00. Now let's explore a more advanced function, a customer rating calculator. The code for this is create function calculate _ customer _ rating, customer _ returns decimal 3, 1 begin declare total _ orders int, declare average _ order _ value decimal 10 2, declare return _ rate decimal 5 2, declare final _ rating decimal 3 1. Comment get total number of orders comment select count asterisk into total _ orders from orders where customer _ ID equals customer _ ID. Comment get average order value comment select AVG total _ amount into average _ order _ value from orders where customer _ ID equals customer _ ID. Comment calculate final rating example formula. Comment set final _ rating equals total _ orders times 0.5 plus average _ order _ value divided by 100. Comment limit rating to max 10.0 comment if final _ rating greater than 10.0 then set final _ rating equals 10.0. And if return final _ rating end. This function uses multiple SQL statements, performs calculations with stored data, incorporates conditional logic, and combines multiple data points to calculate a customer rating. Here's how you can use this function. To find top customers using the function write, select ID name, calculate _ customer _ rating ID, as rating from customer's order by rating desk limit 10. SQL stored functions come in various types, each serving a specific purpose. Let's explore the different types of functions. Scalar functions, table-valued functions, aggregate functions, and system functions. Scalar functions return a single value based on input parameters and are the most common type of user-defined function. Table-valued functions return a table or result set instead of a single value and are useful for complex data retrieval operations. Aggregate functions operate on multiple rows and return a single value and can be used with group by clauses. System functions are built-in database functions that perform system tasks and usually cannot be created by users. To make the most of SQL stored functions, it's essential to follow best practices and avoid common pitfalls. Let's start with the best practices. Use meaningful names that clearly describe what the function does. Add comments to explain the purpose, logic, and parameters of the function. Perform input validation at the beginning of the function to ensure data quality. Keep functions focused on a single task, adhering to the single responsibility principle. Use appropriate data types for parameters and return values to prevent data type-related issues. Consider the performance impact of functions used in where clauses, as they can affect query performance. Now let's discuss common pitfalls to avoid. Avoid excessive complexity to keep functions maintainable. Be cautious when using functions in where clauses, as they may prevent index usage and slow down queries. Handle null values properly to prevent unexpected results. Avoid side effects by ensuring that functions do not modify the database state. Implement robust error handling to prevent mysterious failures. Be careful with recursive calls to avoid Stack Overflow errors. Let's summarize the key takeaways about SQL stored functions. SQL stored functions are database objects that encapsulate logic, accept parameters, and always return a value. They provide a way to extend SQL's capabilities while maintaining consistent business logic across applications. So, what are the advantages of stored functions? Code reusability, centralized business logic, enhanced security, and improved maintainability. When should you use functions? For computations requiring return values, data transformations in queries, complex conditional logic, and mathematical operations. What are the limitations of stored functions? They cannot modify database data in most database management systems, must return a value, may affect query performance, and cannot handle error conditions like procedures. And finally, remember, functions and procedures serve distinct purposes. Testing is essential to ensure the correctness of functions. Database-specific syntax varies, so be sure to consult your database's documentation. Performance impacts should be considered when using functions in queries. If you like this video, hit that like button and don't forget to subscribe. Visit codelucky.com for more such useful content.